Well, hello, good morning, everybody. Let's go ahead and grade our homework from the first unit, the basics on trigonometry. So first thing it says, construct a triangle below accurately, make it a 30, 60, 90, and make it so it fits in this space right here, right? Well, we're on coronavirus quarantine, of course, no school. So I don't have a protractor, so I had to print one. If you don't have a protractor at home, I guess it means this will be a little difficult to do, but you can follow along. Here's what you do. Look, make a triangle. You first start off with just one side. So I'm gonna make one side right here. And I'm gonna make that is so when I'm drawing it, I'm measuring. So I started 19, I went to 26 centimeters, so this is 7 centimeters. You see it says Goldilocks. That just means so that it fits, right? Alright, so now the way you use a protractor, even though this is a paper one, we can still make it work. So what I'm going to make this line longer so that I can be very accurate when I do my measurements. So I got that line going much longer so that I can use my protractor. Okay, so I can't see through my protractor, but I did poke a little hole right here so that I can see how it lines up, you see? All right, now, got it lined up there. Let's see, I got my, it's hard to tell, but on the dot, right here on the dot, I have that centered in the hole, and this is lined up. My line, my side of the triangle is lined up right there, right? So I'm going to make this side my 90. So I'm going to go up here, you see? So this is my 90. So I'm going to connect this dot to that dot right there, and that will be a 90-degree angle. Let's go ahead and do this. Now when you're doing these, so eventually you guys are going to be taking a paper 2 or a paper 4, and you might have to do constructions. Those constructions are measured for accuracy, so you need to be really careful. Did you see how before I drew the line, I made sure that my pencil lead and my ruler were lined up, and then I drew it? Really, really important. Now, so this is my 90-degree angle, right? So now I need to make a 30 and a 60. So with a triangle, you know how they add up to 180, right? I already have 90, so I have 90 degrees left, and that's what 30 plus 60 is. So if I make from here, if I make this either the 30 or the 60, boom, I'm good, I'm done. So I'm going to go ahead and line this up. Okay, it's lined up there, so I know it's hard to see, and this is not the most accurate way. I'm going to go ahead and make this a 30. This is not the most accurate because it's a stupid piece of paper, but I looked everywhere. I don't have one here at my house. I cannot believe it. I can't believe I forgot to get one, but all right, so you see how I put my pencil on it, and then I slid the ruler down, and then my pencil there. So this is my 30 right here, and that makes this a 60. All right. Now, number 2 says measure and label each side. So I already know that that side is 7, right? So let's measure this side. I have to measure it very accurately. Okay, normally, so I have this under the document camera so that the document camera is clear. Normally, you have to put your head right over it. Oh, wow, that's interesting. So this looks like it's 4, doesn't it? Let's see. 1, 2, 3, 4. Huh. Wow, that's strange. Looks like it might be a little bit over 4, but we'll say it's 4. So we got a 7, we got a 4. This is weird. And starting at 1 and an 8. That seems very odd to me. That doesn't seem quite accurate at all, but let's find out. So 8. Oh, wait a minute. I made a mistake. Millimeters. These are centimeters. You see it says right here. It says these are centimeters. Now there's 10 millimeters per centimeter, so each one of these little lines right here is a millimeter. So this is 70, that's 40, that's 81. But I want to double check again because I don't know, I'm just not real happy with how this looks right here. So see, that looks like this side looks like it's actually, man, it looks like it might be 71. I'm going to go ahead and say this is 71 millimeters. And this side right here might be 40. Let's find out. So, I mean, I'm having a hard time because the document camera, I can't put my head right over the top of it. So I'm really being careful to line up that top button, right, that top mark right there. And then this one, That looks like it's right at 40. So I'm going to go ahead and call that 40 millimeters. Okay, and the last one, see if it's really 80 or not. I'm going to start here. That looks good right there. Boy, I'm going to call it 81. All right, so that's what we got. That's our 30, 60, 90 right triangle. Now, that is not very accurate because I was using this piece of paper. So I know it's not going to be real good, but that's okay. Now, got it measured. I got it labeled. Okay, and I did it in millimeters. Do you see? Millimeters. Make sure you read and follow the directions. I almost did it in centimeters. Okay, show that it is a right triangle. So if it's a right triangle, the Pythagorean Theorem should work. So it's going to be 40 squared plus 71 squared equals 80 squared. And I wonder how far off this is going to be. So I'm going to use my handy dandy calculator here. Right? 40 squared plus 71 squared equals 6641. What's 81 squared? Whoa, that's actually not too far off. You know, because we're measuring a pencil lead. We're measuring something drawn with a pencil lead, which is at least a millimeter thick, and we're pretty close. So this side was 6641, and this is 6581. So we're off, but it's close. But that's what I got. So this was when I wrote this. When I wrote these questions, this is what I expected. I didn't expect it to be accurate, like 100%. I just want it to be close. So if you're close, if you drew one and you measured it and you were pretty close, this is pretty close. This is not too far off. Then I would say that you're okay, right? Now, sorry, I had to drink my coffee. For those of you watching this in the future, today is my father's 71st birthday. This is the date. So we are closed because of coronavirus quarantine. So we're doing this all from home instead of in school, right? All right, now, you needed to read the notes that were attached. And if you didn't read the notes, then you're probably confused. If you didn't watch the video and read the notes and take notes yourself, you're confused. But here's how it's going to work. You're going to watch the video. You're going to read the notes. You're going to try the homework. You're going to go back and do it again. It's unfortunate, but that's really kind of how it has to work. We'll do as much as we can live, face to face, and in Google Hangouts and YouTube Live. But really, learning on your own is tricky, and that's one of the things you got to do. Okay, so you got to read, you got to watch, and all the while you got to take notes. Okay, got to. Good notes, not just copying things out. Good notes, where you're writing down questions, you're coming up with ideas, just like you do in class, just like I've taught you in class. Then you try homework. When you get stuck, because you are going to get stuck because it's brand new, then you reread and you rewatch, and then you try again. That's how you're going to do it. If you want to be successful, that's what you're going to do. That's what you got to do. It's really not that huge of a deal. Just be patient with yourself. I know it's frustrating. You want you to relieve your confusion, but you'll be all right. Just be patient. All right. So now we saw with sine SOHCAHTOA. You see, we saw that sine was opposite over hypotenuse. So 30 degrees is right here. You see, opposite is this is opposite. This is adjacent. The hypotenuse is adjacent too, but we don't call the hypotenuse adjacent because it's fixed. So this 40 is the opposite. So here, let's do this right here. Sine is opposite over hypotenuse. So that's going to give us 40 over 81. Do you see? That would be our sine of 30 degrees. Now, where'd my calculator go? Let's see here. Let's see what is 40 divided by 81. Let's see how close we were. 0.49. That's pretty close. That's pretty close because the sine of 30 degrees, as you're going to see, is 0.5. So we're actually not too far off. Our little hand-drawn triangle, I don't think it's too bad. That's not too bad at all. Now, when you plug in sine of 30 into a calculator, the calculator is already programmed with all the values are. And it doesn't matter how big your triangle is. It could be a really tall, tiny triangle, It could be a really, like the one we have here, it could be a really giant triangle. It doesn't even matter. And that's the reason why I did this assignment, is I wanted you to see that lots of people are going to draw lots of different sizes of triangles, and depending on how accurate they are, they're going to be really close to this value. And if you were able to draw it perfectly, you would be exactly that. Cosine is going to be a little different, though. Cosine of 30. Now, we saw that cosine is adjacent over hypotenuse, right? So if we talk about 30 adjacent, 71 over 81. So we said that's 0.49. Let's see what this one is. 71 over 81. 0.88. Let's round it up. We're going to say 0.88. Now, that's kind of close. Cosine of 30 is 0.866. So that's pretty close too. That's pretty close. It's actually it's a square root of 3 over 2 is what it is exactly, and this is 1/2. Like, that's what they really should be, but that's okay. Now, we saw that tangent was opposite over adjacent. You learned that in the notes. So you probably didn't remember that. You had to go back and look. Adjacent, opposite over adjacent. So tangent of 30, here's 30. Opposite is this side to this angle. Now, for 60 degrees, this isn't opposite. This is adjacent. So opposite and adjacent are not fixed. The only side that's fixed is the hypotenuse. The hypotenuse is opposite of the 90-degree angle. So tangent of 30 is opposite over adjacent. That's 40 over 71. Let's go ahead and see what that looks like. Oops. 40 divided by 71. 0.56. Now, I didn't tell you to do it on a calculator, and I didn't expect you to. I expected you to just leave it like this, which is perfectly cool. That's fine. Let's see what tangent of 30 is officially. Oh, wow, 0.577. So that's really, really close. That's kind of cool. We're actually, I'm kind of surprised that using a paper protractor that we could get that accurate. So that's pretty good. Now, sine is, again, opposite over hypotenuse, but now we're talking about 60 degrees. Well, here's 60 degrees right here. So opposite is 71. So the sine of 60 is going to be 71 over 80. 71 over 81. Sorry, 71 over 81. So we already know that that's this right here. Do you see? 0.88. And this is kind of strange. Look at this. You see how the sine of 60 and the cosine of 30? You see how they're the same? That's kind of strange, right? Now, cosine of 60, I wonder if that's going to be the same as sine of 30. So look, here's what we saw. We saw that the sine of an angle, theta is an angle, equaled the cosine of 90 minus that angle. That's kind of strange. Like, look, check this out. This right here, the sine of this angle equaled the cosine of 90 minus this. Do you see? That would be 30. It's supplementary. It's complementary angle. The sine of an angle is equal to the cosine of its complement. That's interesting. Okay. So I'm wondering if this is true. If the cosine of 60 equals the sine of 30. Well, let's find out. Here's 60. Cosine is adjacent over hypotenuse. That's 40 over 81. Holy moly, guacamole. Look at that. 0.49. Same thing. Okay, now tangent's different. Tangent's not going to have that way. It's going to be like the reciprocal, because it's going to be opposite over adjacent. So for here, opposite is 71. And adjacent to 60 is 40. So it's going to be 71 over 40. See, it's flipped over. Kind of cool. All right. Well, let's move on to the second page, shall we? Okay. Now, given the angle K is a right triangle, and has a cosine of 4/5, find the sine. And it says hint, sketch the diagram below. So here's what I know about cosine. I know that cosine is adjacent over hypotenuse, and I know that it equals 4/5 because it tells me, right? So, like, if I had a right triangle like this, right? And let's say this is our angle. This symbol right here, it's a Greek letter. Like, you know how this is a Greek letter and it's pi? Well, this right here is called theta. All right, now 4/5. So adjacent, well, this side's adjacent, so that would be 4, and this is the hypotenuse right there. It's 5. Do you see? Now it says find the sine of the angle. Well, sine Sine is opposite over hypotenuse. So I need this side right there, right? Well, you might recognize right off the bat, this is a 3, 4, 5. This is going to be 3, but so you don't remember that. You would have to use the Pythagorean Theorem, a squared plus b squared equals c squared, right? So it's going to be a squared plus 4 squared equals 5 squared. So it's going to be a equals the square root of 25 minus 16, which is 9. And the square root of 9 is 3. All right, so sine of this is going to be 3/5. So sine of our angle is going to be 3/5. Now, these trig things right here, these are functions. But the input is an angle. That's the input. And it's an angle. And the output is a ratio of sides. It's a fraction. It's a ratio of sides. Now, that's how trig is defined. So it's not like there's a mathematical